All right, our second lesson for today, we're going to focus back on inverses, but this time we're going to look with radicals. So same 4 steps as yesterday. We're going to rewrite the function, taking out the function notation. Most of the times it's f of x. We're going to replace it with y. We're going to switch places for the x and the y's. We're going to solve for y, and then we're going to write our answer in inverse notation. Notice down here I've given you something to keep in mind. To undo powers, we're going to take the same root. So if I have a power of 2, I'm going to take the square root. If I have a power of 3, I'm going to take the cube root. If I have a power of 4, I'm going to take the fourth root. I don't think you get anything bigger than that. And then the opposite is true. To undo a square root, we square both sides. To undo a cube root, we cube both sides. To undo a fourth root, we take the fourth power on both sides. And again, I don't think you get really anything larger than a cube, but just in case. All right, so first question, following those same 4 steps, I don't know why I only have 3 of them left, but we're going to take the function notation out and replace it with y. That's step 1. So still step 1 right there. Step 2, we need to switch x and y, so we're going to have x equals -3 plus y minus 2 squared. Now we want to solve for y. In order to solve for y, y is currently stuck right here in the set of parentheses with the squared. We need to isolate that before we can get rid of the squared. So we need to get rid of that -3 that's sitting out front by adding 3 to both sides. So when I add 3 to both sides, that's going to give me x plus 3 on the left, and then y minus 2 in parentheses squared on the right side. Now I want to eliminate this squared on both sides. In order to eliminate an exponent, I need to take the same root. So this is an exponent of 2, so I need to take the second root, which is the square root. If I'm taking the square root on one side, I also have to take the square root on the other. So we have to keep balanced equation. We're square rooting the left, we're square rooting the right. The left-hand side is just going to stay the square root of x plus 3. Notice the x and the plus 3 are underneath that square root. On the right-hand side, the square root and the squared cancel each other out. They're all gone. You're left with y minus 2. In order to get y by itself, we've got to get rid of that -2. So we're going to want to add 2 to both sides. When I add 2 to the left side, I am not allowed to combine that 2 with the 3. The reason is that 3 is stuck underneath the square root, the 2 is not going to be. So the square root of x plus 3, the plus 2 gets brought over at the end, and then it's going to equal. So you'll notice my square root stops right here after the 3. Then we're just going to rewrite our answer in inverse notation. F inverse of x equals the square root of x plus 3 and then the plus 2. I don't know why I wrote that so quickly. And then this is my final answer. So F inverse of x equals the square root of x plus 3, and then the plus 2 again hangs out at the end. You cannot combine the 2 and the 3 because the 3 is underneath the square root, the 2 is not. Questions on this one? Oops. All right, let's try another one. So again, same 4 steps. We're going to start off with taking inverse notation out, replacing it with y. So y equals the 5th root of x plus 1. The -2 hangs out at the end. Step number 2, we want to switch the x and the y. So I'm going to have x equals the 5th root of y plus 1, minus 2. In order to solve for y, I now need to get the 5th root by itself. So before I can cancel out that 5th root, I've got to get rid of that 2 that's hanging out at the end by adding 2 to both sides. So that's going to give me x plus 2 on the left-hand side equals the 5th root of y plus 1 on the right. Now, in order to get rid of this 5th root, I need to take both sides to the 5th power. So because it's the 5th root, I'm going to take both sides to the 5th power. 5th root and 5th power here are going to cancel. On the left-hand side, technically that's x plus 2 multiplied by itself 5 times. I will never make you actually multiply those together. So we're going to leave it as x plus 2, all in parentheses, to the 5th power. Again, that's really x plus 2 times x plus 2 times x plus 2 times x plus 2 times x plus 2, but we're not going to do all of that work. And now to get y by itself, we're going to subtract 1 from both sides. It's going to give us y equals, in parentheses, x plus 2 to the 5th. The minus 1 just gets written out at the end. Similarly to last time, I can't combine that 2 and the negative 1 because the 2 is in parentheses being raised to the 5th power. Last step, we just want to go back and write this in inverse notation. So f inverse of x equals x plus 2 to the 5th minus 1. Questions on this one? All right. Last one has been labeled an important question. May or may not have a similar question on your phone. So here we're asked to find the inverse of h of x equals, in parentheses, x plus 6 to the 3rd power minus 2. Still going to follow those same 4 steps. So I'm going to take h of x out and replace it with y. Then I'm going to switch or invert my variables. And now I want to solve for y. What should I do first? Yep, get the 2 and move it. I'm going to add 2 to both sides. So x plus 2 on the left-hand side equals y plus 6 to the 3rd power. How do I get rid of that 3rd power? In order to get rid of that 3rd power, we need to take the 3rd root, or the cubed root as it's most commonly called. If we take the cubed root of the right-hand side, we also need to take the cubed root of the left-hand side. So on the left-hand side, I now have the cube root of x plus 2. On the right-hand side, our cube root and our cube cancel, leaving us with y plus 6. I know, I talked to her. Think so. Oh, no, she just told me she had something come up. She wasn't gonna be here. Oh, I need to know. In order to get y by itself, I need to subtract 6 from both sides. As I mentioned earlier, we cannot combine the 6 and the 2 here because the 2 is underneath the cube root. The 6 will not be. So the cube root of x plus 2 minus 6 equals y. And then last but not least, we need to change y to h inverse of x. And then this right here is our final answer. Questions or concerns on this one?